Hi and Assalamualaikum. Today our group will be presenting about chromatography. What is chromatography? Basically, chromatography is a technique used to separate mixture of soluble substance, colored substance such as food colorings, inks, dye, and plant pigment that can be separated by chromatography. So, chromatography is an analytical technique used to separate, identify, and analyze components in a mixture. It works based on the different interaction of substance with two phases. Firstly, the stationary phase, which remain fixed, and the mobile phase, which move through it carrying the sample. Because each component interacts differently with this phase, they travel at different speeds and become separated. This allows scientists to identify and measure the substance present in sample. Chromatography was the first developed by Michael Sweet in 1906 while studying plant pigments. Today, it is widely used in food safety testing, environmental monitoring, and forensic science to ensure accuracy, quality, and safety. So, after all of the explanations, let's take a look of the definition of chromatography. Chromatography is an analytical separation method in which the components of a mixture are distributed between stationary phase and mobile phase. Now, for the objective is to separate the components in a mixture, identify unknown substance, next, determine the purity of compounds. Other than that, quantify the amount of each component, and lastly, purify compound for further use. So, you must think, what is the importance of chromatography? Let me explain. The importance of chromatography is to separate components in a mixture and identify unknown compounds. It also can determine the purity of substance and detect impurities and contaminants. Lastly, it's also widely used in food analysis and environmental monitoring. Now, let's move to the type of sample used. Firstly, we have liquid sample. For liquid sample, we have blood, urine, and water. Next, gas sample. Gas sample, we can take it from air pollens and industrial gas. Third, we have food sample. Food sample, we can look at additive preservation and particle sample. Fourth, we have environmental sample, such as soil, water, and wastewater. Lastly, we have pharmaceutical sample. For example, drug and active ingredient. Before chromatography analysis, proper sampling produced are very important to ensure accurate result. Sample must be collected carefully using clean and submersible containers. For example, liquid samples are collected in sterile bottle, gas sample in gas-tight syringe, and a solid sample may require extraction before analysis. Contamination must be avoided because it can affect the accuracy of the result. This can be done by using clean equipment, wearing gloves, sealing sample properly, and avoiding exposure or dust or chemicals. Finally, sample must be stored correctly before analysis, as improper storage cause a sample degradation can lead to inaccurate result. Sample preparation is also an important step before chromatography analysis. So, let's look it step by step. First, filtration is used to remove suspend particle from liquid samples. Next, dilution reduces the sample concentration when it's too concentrated, preventing the detector overload and improving the analysis accuracy. Finally, the extraction is used to separate the desired compound from the sample. Common methods include liquid-liquid extraction and solid phase extraction. This step removes interfering substance and concentrates the target compound for a better analysis result.
Now I will explain the principle of chromatography. Chromatography is a technique used to separate the component of a mixture. It works because different substances move at different speed between two phases. The first phase is the stationary phase, which stays in one place. It is usually a solid or a liquid coated with a solid surface. The second phase is the mobile phase, which can be a liquid or a gas. It moves through the stationary phase and carry the sample. The substance being separated is called the analyte. The separation happens because each compound has a different attraction or affinity to the stationary phase and mobile phase. Compounds that are more attracted to the stationary phase move more slowly, while compounds that are more attracted to the mobile phase move faster. As a result, the mixture is separated into its individual components for analysis. So now for stationary phase. The stationary phase is the material that remains fixed inside the chromatography system. It may be a solid or a liquid coated in a solid support. Different compounds interact with the stationary phase to different extents. Components that interact more strongly with the stationary phase move more slowly. Next, I will explain about mobile phase. The mobile phase is the solvent or gas that carry the sample through the stationary phase. It can be liquid or gas. The mobile phase transports the sample while allowing the separation process to occur. Next is separation between polarity and affinity. Chromatography separates compounds because they have different polarity. Polarity is different attraction to polar or non-polar substance, and affinity, strength of interaction with the stationary phase. Compounds with higher affinity for the stationary phase travel more slowly, while compounds with higher affinity for the mobile phase move faster. As a result, each compound exits the column at a different time, producing successful separation. To analyze chromatography, we use RF value. RF value are used to identify unknown chemicals by comparing them to a range of reference substances. The RF value for a particular substance will always be the same if the same solvent and stationary phase are used. Types of chromatography: thin layer, or we can also call as planar chromatography. TLC use a thin layer of adsorbent coated on a flat plane. Mechanism: mobile phase move up by capillary action. Qualitative analysis is performed using RF value. Second is high performance liquid HPLC. Advanced instrumentation. HPLC use high pressure up to 400 bar to force the liquid mobile phase through a column packed with very small particles. It was very height sensitive and precision. Automated sample injection, commonly used in pharmaceutical labs. The third one is gas chromatography. It uses an inert carrier gas such as helium or nitrogen as the mobile phase. It's suitable only for volatile and thermally stable compound. Commonly application for gas chromatography is analysis of perfume, petroleum products, alcohol, environment pollutants. For column chromatography, it uses a glass column packed with silica gel or alumina. The sample is loaded onto the top of the column. The solvent carries the compound through the column. Different compounds move at different speed and are collected separately, commonly used for purification in research laboratories. Instrumentation and components. First is injector. Introduce the sample into the chromatography system. Ensure the sample enter accurately and consistently. Small injection volume improves separation quality. Second is column, the most important part of the chromatography system, containing the stationary phase where separation occurs. Column length and packaging materials affect separation efficiency. Third is mobile phase reservoir. Store the solvent for HPLC before it enters the system. Supply a continuous flow of the mobile phase. The purity of the solvent is important to obtain accurate result. Lastly is detector. It detects compounds as they leave the column, convert the signal into electrical data, produce a chromatogram with peak representing each compound. Common detectors include UV detector for HPLC and flame ionization detector for gas chromatography.
Hi, my name is NURFAHIMAH and I will be talking about the analysis process and data collection. Basically, there are three main steps. First, we have sample injection. This is where we inject our sample into the system so it can join the moving mobile phase. Second is the separation in the column. As the mobile phase pushes the sample through the column, the components start to separate because some like to stick to the stationary phase, while others prefer to move along with the liquid or gas. The third is detection process. Once the separated parts exit the column one by one, the detector catches them. Now, how do we actually read this graph, which we call a chromatogram? There are three main things we look at. First, the retention time. This is simply the time it takes for specific parts of the sample to travel from the injection point to the detector. Since every compound has its own unique time under the same condition, we use this for qualitative analysis, which is to figure out what the substances actually is. Next, we look at the peak area and peak height. The peak area is the total space under the specific peak curve. This is super important because the bigger the area, the higher the concentration. So we use peak area and peak height for quantitative analysis, which tell us exactly how much of that substance is inside our sample. Chromatography is very sensitive, so there are a few everyday factors that can change our result. First is temperature. If the system is too hot, everything moves way too fast and the component will not separate nicely. Second is flow rate. If it's moving too fast, the sample does not have time to separate. If it is too slow, the peaks on our graph will look wide and flat instead of sharp. And finally, solvent polarity. In liquid system, if we change the polarity of our solvent, it changes how strongly it pulls the sample through the column, which directly affect our retention time. So, controlling this factor is key to get accurate data. That is all from me. Thank you.
Now, I will explain the interpretation of our result. The paper chromatography experiment successfully separated the food dyes into their individual components. Its separation happens because each dye has a different solubility in the solvent, which is the mobile phase, and a different attraction to the paper, which is the stationary phase. From our result, the blue dye show only one color spot indicating that it is a pure dye. The red and yellow dyes also produce one spot each, meaning they are pure substance. However, the green dye separate into two different color spots, which were blue and yellow. They show that the green dye is actually a mixture of two different dyes rather than a single pure compound. Accuracy refers to how close our result are to the true or correct value. We improve accuracy by measuring all distance carefully, making the solvent front immediately after removing the paper, avoiding contamination, and applying dye spot of equal size. Precision refers to the consistencies of repeated measurements. To improve precision, we repeat the experiment using the same solvent and procedure, measure the distance carefully with a ruler, and keep all experimental conditions constant. By following this step, we were able to obtain results that were both accurate and reliable. Paper chromatography has many important applications in different fields. In food analysis, it is used to identify food colorings, detect additives or contaminants, and ensure food quality and safety. In the pharmaceutical industry, chromatography helps test the purity of medicines, identify active ingredients, and detect impurities during the manufacturing process. In forensic science, chromatography is used to analyze ink from questionnaire documents, detect drugs and poison, and assist criminal investigation by providing important chemical evidence. To conclude, the experiment showed that paper chromatography is an effective method for separating food dyes. The blue, red, and yellow dyes each contain only one component, indicating that they are pure dyes. In contrast, the green dye separate into two blue and yellow components, provided that it is a mixture. This experiment also demonstrates that paper chromatography is simple, fast, cost-effective, and reliable for separating and identify color compounds. Overall, paper chromatography is widely used in food analysis, forensic science, pharmaceutical industry, and environmental testing because of its effectiveness and accuracy. Thank you.